Good day, chemistry students. Thanks for checking this video out. Today I'm going to walk you through how to write formulas for polyatomic ionic compounds. Very similar to what we did in the last lesson, which was involving monatomic ionic compounds. So I guess the first thing we need to do is define just what exactly a polyatomic ion is. So first of all, a monatomic ion is what we've been working with. This is when a single atom has ionized and has a charge. So examples of that would be potassium with a +1 charge, or calcium with a +2 charge, or chlorine with a -1 charge, or oxygen with a -2 charge. Those are all individual atoms that have ionized. And the root, or the prefix rather, in the term monatomic is mono. And you probably know that mono means one. So on the other hand, a polyatomic ion is a covalent compound that has ionized. So poly means multiple or many or two or more in some contexts. So this is going to be, let's say, two or more. And it's two or more atoms, polyatomic, that have joined together to form a covalent compound that has a charge. So some examples of these would be NH4, which is the only positively charged covalent polyatomic ion. And another example would be CO3, which is a polyatomic ion called carbonate, and it is what gives your carbonated beverage its fizzy flavor. And yet another example would be, let's see here, phosphate, PO4 with a -3 charge. So you'll notice in each case that each of these ions consist of multiple atoms. So even though they are compounds, we treat them just like we would treat a monatomic ion. So a little bit more here. Why would a compound, first of all, ionize? A good example is to look at NH4. And if you make the Lewis structure for NH4, remember Lewis structures from trimester 1, we count up the valence electrons and we see that there are 9. And when you try to do the Lewis structure, you will have a hard time finding a place for that last electron. It really doesn't fit in there anywhere after we've completed the valence shells for all these atoms. And indeed, that is why this particular compound gets rid of the 9th electron. And of course, when it loses the negatively charged electron, it's going to leave it with a positive charge. So in short, NH4 is more stable when it has a positive charge. Here's a photo showing some other ionic compounds. Don't need to get too into that right now. Let's jump right into the examples on page 24. We want to figure out how to write the formulas for ionic compounds. So example 1 on page 24 asks you to write the formula for sodium phosphate. So I always like to divide the name into its two parts. So on the cation in this case is actually a monatomic ion. It is sodium with a +1 charge. But it is paired up with a polyatomic ion, which is PO4 phosphate with a -3 charge. So we're going to fill out a T chart just like we did with the monatomic ions. Sodium has a +1 charge, as we said. Phosphate has a -3 charge. So they do not neutralize each other currently. And hopefully it's obvious to you the solution here. We're going to need to add a couple more sodium ions to balance out the -3 charge of the phosphate. Now we have a neutralized compound, so the formula is going to be 3 sodium atoms in A3 and just 1 phosphate, so PO4, and we don't put a 1 as a subscript, we just leave it as is. So that is the formula for sodium phosphate. Let's do example 2, which is a little bit trickier. What is the formula for ammonium carbonate? So again, let's put a line there dividing the cation from the anion. So ammonium is a polyatomic ion. It's got more than 1 atom in it. It's the only polyatomic cation. Carbonate is also a polyatomic ion, and it has the formula of CO3, and it is -2. So again, we are writing the formula for ammonium carbonate. So let's start filling our T-chart in. NH4 has a charge of +1. CO3 has a charge of -2. They do not currently neutralize each other. Again, the solution should be pretty obvious to you. We're going to need to add another ammonium to neutralize the -2 charge of the carbonate. Here's where it's a little bit tricky, and you really want to pay attention to this. We need 2 ammoniums. So I'm going to put NH4 down here. But I'm not going to put a 2 subscript just next to the 4 because then it looks like I have NH42, which is definitely not the case. So I need to put the whole polyatomic ion, NH4, in parentheses. And then I'm going to put the 2 outside of the parentheses. And then that 2 applies to everything in the parentheses. So I've only got 1 carbonate up here, so I'm just going to put CO3. Notice I don't put the charges on the ions when they're in the compound because technically the compound has a neutral charge. I only put the charge on the ions when they're written by themselves. So let me talk more about the parentheses here and the 2 subscript, just what that means. What that is indicating is that we've got 2 of these covalent compounds, NH4, which I can draw sort of the simplified Lewis structures for. So that is what that is communicating. And we can add all those atoms up. It's actually 2 nitrogens and 8 hydrogens in total. So that's how we write the formula for ammonium carbonate. As always, reach out if you have any questions. Thank you for taking the time to watch the video. Have a great day.